Hello students, today we'll complete the first topic of refrigeration and air conditioning, which involves some basics of refrigeration and air conditioning, methods of refrigeration and air conditioning, and applications of refrigeration and air conditioning. I am Professor Nilesh Dogne. Introduction. So first of all, what is meant by refrigeration? It is nothing but the process which cools the space by removing heat from it, and temperature of body is reduced compared with its surrounding is called as refrigeration. According to the ASHRAE, American Society of Refrigerating Engineers defines refrigeration as the science of providing and maintaining temperature below that of surrounding or below that of atmosphere. Now, what is the difference between cooling and refrigeration? Cooling can be spontaneous process and the final temperature need not be the lower than the surrounding atmospheric temperature. Whereas in refrigeration, it is not a spontaneous process. It is cooling some space, cooling some object, and the final temperature should be lower than the surrounding. So we maintain the temperature below surrounding in case of refrigeration. For example, cooling hot cup of tea. So this is example of cooling. Cooling of glass of water by adding the ice is nothing but the refrigeration. The final temperature is less than the surrounding. Cooling of water in earthen pot. The final temperature is less than the surrounding temperature. The next slide will see the application of refrigeration. So some basic applications I have discussed here. The first one is food processing and food preservation. So for food preservation, like we are using at home for keeping vegetables, fruits, milk products, water and ice formation in domestic refrigerator. Next is some chemical process industries also need a refrigeration. So chemical reactions need to be done at a lower temperature than the atmospheric. Next is comfort air conditioning. So this is a very common nowadays and it is extensively used in residential buildings, hospital, offices, working spaces, vehicles, trains and aeroplanes. Everywhere you find the air conditioning nowadays and it is a very common one and essential also. Next is the industrial air conditioning system. So the difference between comfort and industrial is comfort means for comfort of human body and industrial air conditioning means for doing some industrial processes where the less temperature or some specific environment is required. For example, it is used for spot cooling or heating, environmental laboratories, printing industry, textile industry, precision parts manufacturing, photographic product handling, computer rooms, etc. So such type of air conditioning come under the industrial air conditioning application. And some miscellaneous applications like in medicinal industry or in some construction work also we need to use the refrigeration. So there are different methods to carry out refrigeration means decreasing temperature and maintaining that below the atmosphere. The very first one that we will see is the natural refrigeration. So refrigeration by natural ice. So ice which is naturally manufactured, it is transported from colder region, harvest ice in winters and store it for summer. It is an old method. Then some refrigeration by using evaporation, cooling by salt solutions. These are come under the natural refrigeration methods. Now there are so many limitations for the natural methods of refrigeration, like it depend on local condition, uncertainty due to the dependence on the weather, difficult to produce large refrigeration effect, and not available to everybody. So in environments where the naturally ice is available, only they can use such type of methods. In country like India, at most of the places, the temperature is always higher than 0 degree Celsius and it is not possible to get ice naturally for most of the time. So the next one is the artificial refrigeration method. So in which there is a gas cycle refrigeration in which compression and expansion of gas is done. Refrigeration by the throttling processes. and vapor refrigeration system. The vapor refrigeration system is subclassified into vapor compression refrigeration and vapor absorption refrigeration. These two are nowadays very common methods, vapor compression and vapor absorption, and in this subset, we'll concentrate on these two methods. Along with this, we have steam jet refrigeration, thermoelectric refrigeration, vortex tube refrigeration system. So, again, we'll go back to the conventional method or the natural method, that is natural refrigeration, which is nothing but the ice refrigeration. So if naturally we have the ice available, so how that ice can be used to carry out refrigeration, or how the such type of refrigerator can be made. Here in the figure you can see what is ice refrigeration. It is one of the oldest method of refrigeration, and this is the cupboard made so that ice is kept at the upper level, and how it cools the remaining compartments where we can have some stuff like food, some milk products which we want to keep at lower temperatures. And at lower there is some container is there which takes or which collects water which is there after melting the ice. So why this method is used? Because the latent heat of fusion of ice is 335 kJ per kg. Therefore, ice can be used to produce cold in a confined chamber, which can be used to store vegetables or foods. When air comes in contact with the metallic surface in which ice is kept, it gets cooled, density of air increases, and it starts moving downwards, and the low density air from the low level compartments moves upward and creates convection current, and so that we get a cooling effect in all the compartments, and ice is kept in the uppermost compartment. So this is nothing but the ice refrigeration system. Along with this, we have some non-conventional methods also of refrigeration. So one by one we'll see this in short, but we'll not spend much time on this. The one is the evaporative cooling. So how it works, you can see the principal diagram and description here. When air is expanded from pressure of 5 bar and temperature of 25 degrees Celsius to atmospheric pressure of 1 bar, its temperature will fall to sub-zero temperature. So this principle is used here and air get expanded. So this low temperature air is used for the refrigeration or cooling purpose. Simultaneously, water is supplied to the chamber to mix with air. The high velocity air forces the water and causes it to break up into tiny droplets, that is fog. Since the surrounding air temperature is below sub-zero temperature, the water droplets will condense and freeze, forming small particles of ice. So this is how we get a cooling effect, and that cooling effect we can use for the refrigeration. So this is nothing but the evaporative cooling. Next is the steam jet refrigeration. Again, here you can see the concept diagram. So instead of giving more time to this, we'll move to the next one. You can have a look on this. So how the steam jet is used to do the cooling effect. Next, thermoelectric refrigeration. So it works on the principle of Peltier effect. Cooling is produced at one junction of two dissimilar metals. If a current is passed through them, simultaneously heat is produced at other junction. So on left hand side you can see the concept diagram, how the one end is at lower temperature and one is at the higher temperature. So it is called as cold junction and hot junction, and how actually it can be used in some refrigerator. So right side diagram, how by using the thermoelectric refrigeration system, how it can be used in some actual machine. Now we'll differentiate between heat engine, heat pump and refrigerator. Already we have studied heat engine in basic thermodynamics as well as the applied thermodynamics. So heat engine nothing but the device which operates in a cycle and converts heat into useful work. So according to the first law of thermodynamics, all the form of energy are convertible from one form to the another form. But according to the second law of thermodynamics, it has some limitation. So you can say Here in the diagram, high temperature source and the low temperature sink. Q in, heat is taken from the high temperature source and some part of this heat is converted into some useful work, W net, that is the output, and remaining part of the heat is rejected. So 100% conversion of heat into work is not possible. So some part of heat is converted into work done. So heat engine receives the heat from high temperature source, convert part of this heat into work, rejects remaining waste heat to the low temperature sink. Then it operates in a cycle. So there are different cycles also we have studied. In applied thermodynamics, we have studied the external combustion engines and internal combustion engines and how they operate on Otto cycle or diesel cycle. That cycle also we have completed in the basic thermodynamics. So the efficiency of engine can be found out by output upon input. So efficiency of engine, heat engine, is nothing but equal to work produced upon heat supplied. Here output is work produced and input is how much heat we are supplying. So efficiency is equal to W out upon Q in, output upon input. Next we'll see what is meant by the heat pump. So it is nothing but the device that transfers heat from a low temperature medium to high temperature is called as heat pump. Heat engine is power producing device, whereas heat pump and refrigerator both are power absorbing devices. So here in the right side diagram you can see the direction of arrows are exactly opposite as that of the heat engine. So here work need to be provided so that this heat pump can be operated. By taking work, so input here is the work, it absorbs heat from the low temperature environment and reject it to the high temperature region, that is warm house or the space which we are going to heat. That's why it is called as heat pump. It is pumping heat from the low temperature region to the high temperature region, and as it is not natural that heat always flow from high temperature to the low temperature, and here we have to do the reverse. We have to take heat from low temperature region and we have to give the heat to the high temperature space. That's why external work is required. So external work is provided here and it is called as the heat pump. Heat pump extract the heat from low temperature medium, delivers the heat to the high temperature medium, and for this it required to do some work need to be provided. That's why it is called as power absorbing. It absorbs power for doing its function. It operates in a cycle. Heat is rejected is desired output. We are interested in the how much heat is rejected or how much heating is done. So the performance of heat pump is measured in coefficient of performance. In case of engine, we have written efficiency of heat engine, but in case of heat pumps and refrigerator, we use the term COP, that is coefficient of performance. So coefficient of performance of heat pump is the basic fundamental is same, output upon input. Here output is how much heat is rejected and input is how much work we are supplying to the heat pump. That's why COP of heat pump is equal to heat rejected upon work supplied. So COP of heat pump is equal to Q out upon W in. Now third one we'll see is the refrigerator. So here you can see the direction of arrows are exactly similar as that of the heat pump, but still it is different from heat pump because here our main aim is to do cooling, and in case of heat pump we need to do the heating. So refrigerator is a device that extracts heat from a low temperature medium and it lowers the temperature of desired space. Though the direction of arrows are same, it is also consuming work like heat pump, but here we are interested in low temperature region or the low temperature space. Here our aim is to do the cooling. So it extracts heat from low temperature medium delivers the heat to the high temperature medium, requires some work, and it operates in a cycle, and it cooled the space. It is our desired output. So this is the different from the heat pump. The performance of refrigerator is again the same thing, output upon input. So here output is how much heat we are removing from the cold space, or how much refrigeration effect we are carrying out upon input is nothing but the work supplied. So COP of refrigerator is equal to heat extracted upon work supplied. COP of refrigerator is equal to Q in upon W in. So here in a single slide you can see the basic difference between heat engine, heat pump and a refrigerator with reference to the surrounding temperature TS. So in case of heat engine, we need a heat source which is comparatively at a very high temperature, from where we take heat and some part of that heat is converted into some useful work, and remaining heat is rejected to the surrounding. While rejecting it, the temperature of this working fluid or the flue gases is slightly higher than the atmospheric temperature that you can see in the diagram, and this is power producing device. In case of heat pump, our aim is to heat the space, and we take heat from the surrounding which is almost at a temperature of surrounding temperature or slightly lower than the surrounding temperature, and we reject that heat to the hot temperature region or the high temperature region. And for doing this, because it is not natural, naturally heat flows from higher temperature to the low temperature. That's why external work need to be required. So this W net is nothing but the work we are providing so that heat can be taken from low temperature reservoir and given to the high temperature reservoir. Now the heat pump and refrigerator though look like same. Heat pump we are interested in heating space, and in refrigerator we are interested in lowering the temperature of some specified region, or we are interested in cooling. So we take heat from the space which is at much lower temperature than the surrounding, and we reject it to the high temperature reservoir which is almost equal to temperature equal to surrounding temperature, and here we are interested in cooling. In case of heat engine we find out efficiency, in case of heat pump we find out COP, and in case of refrigerator again we find out the COP, coefficient of performance. Now in this subject our attention is on the refrigeration. So in this slide we'll see the refrigerating effect and unit of refrigeration. Refrigeration effect is the amount of heat extracted from refrigerator or from the refrigerated space. This refrigeration effect is defined by the unit of refrigeration, and it is called as turn of refrigeration, and sometimes in short it is called as TR, turn of refrigeration. So what is meant by 1 turn of refrigeration? So 1 turn of refrigeration can be defined by the amount of heat being removed from 1 ton of water at 0 degrees Celsius to form 1 ton of ice at 0 degrees Celsius within 24 hours. So from the definition we can find out the equivalent of 1 ton of refrigeration. So 1 ton of refrigeration is equal to mass of water. So how much water we are cooling? 1 ton, that is 1000 kg. The latent heat of that water to convert from water to ice. So latent heat from and at 0 degrees Celsius is 334.5, and how much time is required for this? 24 hours. So we need to convert that time into seconds, so divided by 24 hours into 60, so that will be minute, again into 60, so that will be the seconds. So 1 ton of refrigeration is equal to 3.517 kilojoule per second, or 3.517 kilowatt or 221 kilojoule per minute. So this is the unit normally we use for measuring the refrigeration effect, and that 1 ton of refrigeration is equal to 3.517. Normally while solving numericals you may find this 1 TR is equal to 3.5 kilowatt it is used. Now we'll move to the specific applications of refrigerator. So here in this image you can see the domestic refrigerator, which is very common one. You have seen this at so many places, at home, hotels, hostels, okay, at so many places. So this is the normal appearance of domestic refrigerator. Domestic refrigerators are used to keep the food articles, milk and all these things. So it has such type of compartments. Design may vary according to the brand to brand, and it works on the principle of vapor compression refrigeration system. So in this image you can see some basic components which are there in domestic refrigerator, or the basic components of vapor compression refrigeration system. At the lower side there is a compressor, then there is a condenser, then capillary tube, which is nothing but the expansion device, and finally the evaporator. So these are the four important components any vapor compression refrigeration system has. So here also one more diagram we will see. There is a compressor, condenser, capillary tube or expansion device, and evaporator is shown. One more diagram I will show you this. So this is how the domestic refrigerator is. So here what happens, the if you see the domestic refrigerator at your home, at the lower back side you will find there is a black colored hermetically sealed compressor is there. It is making some small noise also, so we are used to that noise, but you can hear it if you listen carefully in your kitchen. So this compressor compresses the working fluid. So the working fluid used here is refrigerant. So compressor compresses the refrigerant, and due to compression its pressure and temperature of refrigerant is increased. So this refrigerant at the time of compression is in the vapor form. So this vapor refrigerant gets compressed, and due to compression its temperature increased. Then this high pressure, high temperature vapor form of refrigerant will enter to the condenser. So the condenser is nothing but the heat exchanger, which exchanges heat to the surrounding, or which gives out heat from refrigerant to the surrounding. Here the refrigerant flows through these tubes. In old type of domestic refrigerators you will find black colored net like structure at the backside of your refrigerator. This is nothing but the condenser. And in new refrigerators such type of structure is not available, but if you touch your domestic refrigerator on left or right side you will find condenser is there. You will feel hot than the atmospheric temperature. It is due to the condenser, it is not a malfunction. Okay, it should be there. So in condenser, when this high pressure high temperature vapor form of refrigerant flows through the condenser, it gives out heat to the surrounding as surrounding temperature is less than the refrigerant. By rejecting heat to the surrounding, that refrigerant gets converted from vapor form to the liquid form, and that's why this heat exchanger is called as condenser, because refrigerant get condenses in this heat exchanger. That's why it is called as condenser. At the end of condenser you will have the high pressure atmospheric temperature liquid refrigerant. Then this high pressure atmospheric temperature or approximately atmospheric temperature liquid refrigerant will enter to the expansion device or expansion valve. So there are different types of expansion devices are possible, like capillary tube, solenoid valve, thermostatic expansion valve, automatic expansion valve. By using this expansion valve, the pressure of this refrigerant is decreased from condenser pressure to the evaporator pressure. Due to this sudden decrease in the pressure, this is the throttling process. Due to this throttling process, the refrigerant temperature much decreased and it is below 0 degrees Celsius in case of domestic refrigerator. This low pressure, low temperature liquid refrigerant then enter to the evaporator. So evaporator is inside your domestic refrigerator, mostly at the freezer section, which is at the upper side. Evaporator is also the heat exchanger which exchanges heat. So when this low pressure, very low temperature liquid refrigerant enters the evaporator, it absorbs heat from the surrounding, carrying out a refrigeration effect or carrying out cooling effect. This is our desired effect, and due to this heat taken by the liquid refrigerant in evaporator, we get a cooling effect in domestic refrigerator. This refrigerant, by taking heat from the surrounding, gets converted from liquid to vapor, and that's why this heat exchanger is called as evaporator, where refrigerant gets converted from liquid to vapor. Then this low pressure, low temperature vapor refrigerant is again sucked by the compressor. Again compressor compresses it, then it will go to the condenser, it gets condensed, then expansion device and again evaporator, and the cycle continues. This is how your domestic refrigerator works. So I will share with you some videos in which you can see the working of domestic refrigerator in my next video. So here I have link, but I will share with you these videos separately how the refrigerator will work. There is a one more term, defrosting. So I will explain you short what is meant by defrosting. So in case of old refrigerators, in freezer section, after some time, maybe after 5 days, 10 days or a month, there is a ice formation is there, and that is called as frosting. Due to this frosting, the heat transfer capacity or the heat exchange capacity gets decreased. So we need to remove that ice, and that process is called as the defrosting. There are different ways of the defrosting. Like we can stop the operation of domestic refrigerator, we can keep the door open so that after some time that ice will get melt due to surrounding temperature, and this is the defrosting. We can reverse the process of refrigerator, we can heat it by some other means. So there are the different methods of defrosting, but defrosting is required, then only the heat transfer capacity of evaporator will be good. Nowadays in new refrigerators there is no problem of frosting, as it stop its operation if there is a no load. So the next application of refrigerator and vapor compression refrigeration system is the water cooler. In the image in front of you, you can see how the water cooler look like. So this is a very common one. Even in colleges also, universities, we have such type of water coolers, and it again works on the same principle as that of your domestic refrigerator, that is vapor compression refrigeration system. These are available in different sizes from 25 liter to 400 liter, and here difference is that the evaporator coils are dipped in the water, and that's why we get a cold water at the outlet. Deep freezers at different shops or malls, you may have seen such type of deep freezers which are used to keep the ice creams and some other stuff which need to be stored for long duration. So these deep freezers also work on the same principle of vapor compression refrigeration system. They may look like this also. The next application